Hello, I'm Mr. Duda with STEM with Mr. Duda. This is my Arduino starter kit series, project number 11, Crystal Ball, and this is my favorite project to do with my students. I think it's so much fun, and the ability to change some things about it makes it even more fun. To get here, obviously check out the other projects first. Everyone sort of builds on one another. So check out the other ones first. I've got them in the playlist, so hopefully that's on one of the sides or at the end of this video. And yeah, we'll get started. So to get here, you want to log into TinkerCAD. Now you can do this in real life if you have an Arduino. If you have the starter kit, that would be perfect, rather than sourcing out other parts. So if you're doing it in person, you don't need to go on TinkerCAD. But if you don't have an Arduino, you can go on TinkerCAD. So log into TinkerCAD. It's tinkercad.com. You are then going to click Learn. You are going to change this to Circuits. Go over to Projects. Click Show All Arduino. All the ones with the more solid backgrounds, these, I have made videos on. All of these, all the way up until now, Crystal Ball. So I have 4 left that I believe I'll be doing. And maybe by the time you're watching this, they're posted already. So let's begin. We click on Crystal Ball. In this project, you will create something similar to a Magic 8 Ball. But you can edit it, which is cool. Ask it a question, yes or no question, press a button. Interesting. Mine, you didn't have to press a button. So we'll look into that. And a liquid crystal display, LCD, will tell you if your future is bright. Obviously, this is joking around. It's just fun. It's not telling you your future, or is it? You can even write your own responses to display. As always, I will not read through all this stuff for you. You can read through it. I won't waste your time with it. Obviously, reading it will add a better understanding for everyone. This is an Arduino. It's a microcontroller. There are input-output pins here. These are all digital. And then input analog pins. And then this is your power sources that we will use. This is called a breadboard for prototyping stuff, so you don't have to be soldering everything together. It talks about what the project will do, sort of how it's set up. It says you need a tilt switch. See, they said press a button. I don't think you need that. The tilt switch should work. Potentiometer, that is for screen brightness, I believe, a 220 ohm resistor, a 10 kilo ohm resistor, and an LCD panel. And there's a lot of wires to wire up the LCD panel. So it might look a little complicated, but we'll go through it. Don't worry about it. Okay, talks about the LCD display and sort of how to use it. So go ahead and you can read through that, but we're going to be using a library called Liquid Crystal, which already has the programming so we can interface with that LCD without having to write up a bunch of stuff. And you'll see that in the programming in just a little bit. So let's move forward to setting up the circuit. It's nice and easy. We're going to be providing the positive and the negative, and as all the other ones, we're providing 5 volts to that positive rail. So we run 5 volts to the positive rail, make it red because red, that's always positive, right? Keep things organized, makes your life a lot easier. As you'll see in my previous ones, some of them were the wrong colors, and I ended up changing them to make more sense out of it. So now we have 5 volts running here, which makes all of these 5 volts positive, and then the grounds, this entire is grounds. Then we move forward, and we add our tilt switch. Now, if you're doing this in real life, you might want to actually, like look up what it looks like, but mine were all rectangular. They were a little bit taller than they were wide, and they're pretty straightforward as to what it is. But here you can, I don't know if that'll work. Yeah, just type tilt and it'll show up. If we look, we've got the tilt, and I believe there's just 2 wires. There should just be 2 wires, 1 wire here and 1 wire here, and we're going to connect it to 3 and 4. So I'll just drag this over to 3 and 4. Now they had it down farther. I don't know what's going on with this. Maybe it's I guess it has 4 terminals. That's interesting. So maybe you can't connect it there. So I'll just connect it here. So if we look, it does have 4 terminals. I apologize for that. It has terminal 1 and 2. I believe those are both connected to the same exact thing. And then 3 and 4. And basically what it has is when it moves, it either connects 1 and 3 and 2 and 4 together, or it disconnects those. And then we can read a change in state on that. and we can do something with it. So as always, we're going to run positive to the one side. So if we run positive to this side, what color should it be? It should be red because it's positive. Keep nice and organized. Then we have a resistor. Now, I believe this would be as there was a PlayStation research and development engineer out of California that I was talking to on Reddit, and he he was very adamant that I make sure to mention, and I believe this would be the case where it would be this is a voltage divider. That's the reason for this for this resistor. He was very, very adamant. He would not uh, he would not give up the idea. I said, "Oh, it's to keep everything safe," because I didn't want to complicate things too much. And he kept saying, "No, it's a voltage divider." So it's a voltage divider, and what it's doing is making sure not in so not all the voltage when this tilt switch connects these two terminals together. Not all the voltage jumps to ground. That some of the voltage jumps to ground, and then some of it goes to the input pin, which we will be connecting to number 6. So we're running this to number 6, and this is an input pin. So the electricity is running here. If this tilt switch is moved, it will connect to this pin. The electricity, some of it will go to number 6. Some of it will bleed off into the ground. Now, let's make sure this is the correct one. The way you tell is by colors. So I click on it. And in this case, we're supposed to use a 10 kiloohm. So you make sure the correct kiloohm is chosen. If you're doing this with your Arduino, you just want to look at the colors and make sure they match. It goes brown, black, orange, maybe gold, whatever that would be. I'm not sure. But in this case, it goes brown, black, orange, gold. It is in the opposite direction. Resistors are omnidirectional. They can go both directions. A diode can't. A resistor, as far as I've ever known, it doesn't matter which direction it's facing. A diode, a light emitting diode, and only both of those, they only let electricity through one direction. So you have to make sure it's facing the right direction. So far, these two components, the direction doesn't really matter as far as I know. But if it doesn't work, maybe switch the direction of some of those components and we'll see. Now we need to connect the LCD, and it tells us all about what connects to what. It says the register select pin controls where the characters will appear on the screen. As we look at, if we look here, here's the diagram for it. Right, so register select would be number 4. Then it says the RW puts the screen in read or write mode. Obviously to change it, you don't want to have to constantly send a signal to this thing. So as long as there's power, it'll keep it as long as it's in read mode. And then it changes to write mode when you want to change it. The enable, EN, tells the LCD that it will be receiving a command. So here's, where's EN? I'm guessing E is the enable. Perhaps that's it. The data pins, D0 through D7, are used to send character data to the screen. So those would be the letters. All right. And then finally, there's a connection VO for adjusting the contrast. So that would be changing the, I'm guessing yeah, I mean, it's going to change the voltage and it'll change how bright the backlight is. Okay. All right. So let's go to the next step and we'll see how they're connected. So we're going to run our LCD. Please, 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 please be careful. If you're doing this with an actual LCD, please don't force anything. I don't want it getting ruined. That would be a bad thing. So please be careful with it. When I drag this out, you will notice it is, well, let's look. So when I look at this picture, you'll notice it is actually connected to those. Now, if I drag this over, it is connecting. I know you can't really tell. The problem is it's over our screen. Now, there's a way to rotate it. And if you press R, glad I chose the correct one right away. That was pretty lucky. And you'll notice as we go over it, I do believe that it's connecting to all the pins. I sure hope it is. Otherwise, we're going to have to run extra wires. And it starts all the way from the end here over. And those are all red. And we'll see what's going on with that in a minute. So this is correct. And it was, I just want to make it match. There were 4 visible. So let me move up 1. All right, now we connect a positive to the VCC, and the negative would be the ground. So we're giving it power. So positive runs to positive. Remember, these are all connected. We make it red because it's power. We ground this one. So this is now grounded. This one has power. And if I mouse over, this tells me this is the ground, this is the power. Then we look here and we have the read write grounded. Read write grounded, make it black. All right, then we move over and we see, let's just do this one first. This last one is grounded as well. So LED grounded. The reason why this would be, as far as I know, is because the other LED would be the positive. Yeah, LED anode, LED cathode. So positive would be running here, but in this case, we need to add a resistance because it's an LED. We don't want to burn it out. Okay, we don't want to add too much power into this and burn out the component. That guy on the Reddit forum, feel free to comment right there. You work for PlayStation. I trust your opinion. And then we need a resistor. Okay, so we're looking at a 220 ohm resistor. Remember, the colors tell us that it's correct or not. In this case, we take the resistor and it runs to positive because this one was negative, and we make it sure it's 220 ohms. On here, we change this to ohms and we say 220. If you are doing this with yours, make sure the colors match. Red, red, brown, whatever that is, gold. Red, red, brown, gold. You'll notice the direction matches. Remember, you could just grab this, watch, and we can press R and we can flip it over so it'll match maybe what you were getting. I believe it matches this one now. Yeah, so they just rotated that. Once again, it doesn't matter the direction on those. Then I believe we're done on that, so we move forward. Now comes the a lot of wires. Remember, the colors don't matter in this case. Just don't make them red or black. Maybe don't make them green. You could do a rainbow. I'm going to match them just because it's nice. Purple, blue, green, red, and this goes to 2, then 3, then 4, then 5. Why they did it that way, I'm not sure. I would have made it a little cleaner, but maybe when this was originally programmed, the screen was in a different location. So 7 goes to 2. So let's do that. 7 goes to 2, and they made it purple. If you were doing this with your actual one, the colors don't matter at all, okay? They're just to keep you organized, okay? I think it was blue. Once again, the colors don't necessarily matter, okay? I mean, they don't matter at all other than your organization. And so I'm just going to grab random colors because it doesn't really matter. Awesome. So then we've got 2 running to 7, 3 running to 6, 4 running to 5, and 5 running to 4. I believe that's all we needed. We have this running there. I think this should be the last one. Let me just double check that. Yep. All right. Then connecting the LCD. So then what we need, you'll see they're running the RS going to 12 and the E running to 11. So this running to 12, this running to 11, and then you should change the colors on those. I believe this one was orange. Once again, the color doesn't matter. Just make sure maybe it's a different color so you can, tell that it's something other than the other things, okay? So now we're not getting them all confused and all that stuff. And that way, when you get a jumble of wires here, because you will, you can say, oh, the pink's here. Where did it run? And you don't have to follow that wire. You can just look where the pink's connected. All right. Wonderful. let's move on to the last step. We're going to add the potentiometer. Now, a potentiometer is a variable resistor. As you twist the knob, it changes the amount of resistance. Therefore, it changes the amount of electricity flowing through it. They have the potentiometer hooked up at 10, 11, and 12. So we take that, hook it up at 10, 11, and 12. If we look, there is terminal 1, terminal 2, and the wiper. So this is, well, let's connect those. So we have positive running to 10, make it red. I would run that under that wire so you have more room if you're doing this in real life, ground it, black. So what we've got is power running onto this side. It runs through a resistor onto this side. And as you move this, it slides a metal piece and it makes the electricity have to flow through less of that resistor, so it resists less. So the more you move it, either direction, it changes the amount of electricity that is coming out. And then we are running, and this is interesting because this potentiometer does not, you'll notice, this potentiometer has its wiper here on the top, and then it's running to that V, I believe it's a 0. This case it doesn't, but none of these are connected to anything else, so we can just connect here to V0, okay? And it could be to any of those. And they were green, so I'll leave it green. Yours might have been up there and you run it there. Either way, there's going to be electricity flowing through, and then this will read how much electricity is coming through, and it will change the brightness of the screen, okay? If you want to erase something, I think you hit delete, yeah. All right, let's move on to the programming. As always, I use the code straight from Arduino, written by Scott Fitzgerald. Shout out to him. I get here by going to create.arduino.cc, examples, starter kit, basic kit, crystal ball, and I'm going to copy all of this. The reason why I use it and I prefer it is because it has all the notes, and any good programmer is going to put notes in there so when they go back, they can make changes, and also if it's open source and they're providing that code to other people, it makes it much more useful. So I'll just paste it in there and we will go through it. Obviously, you can read through the directions here. Maybe it'll make more sense than how I describe it. So if you're still confused, once I'm done talking, feel free to check those out. So it says Project 11 Crystal Ball, Scott Fitzgerald. Thank you, Scott. And it's for the starter kit. They want to include the liquid crystal library that basically tells the Arduino how to interface with the LCD screen. And then initialize the library with the number of the interface pins. So it's saying, so we've got 2, 3, 4, 5, and 11 and 12. Those are the ones connected to the LCD. And this would, as far as I know, the order would be described based on what's in the liquid crystal code. So it's probably instantly saying, by doing that, it's saying 12 is the register, 11 is the enable, okay? And that order tells it exactly that. Now, I just want to make sure, hopefully, if there's any mistakes here, we'll have to change some of those wires, but I'm guessing it's set up correctly. It's saying create an integer called switch pin. We're saying switch pin is on number 6. So if we look at 6, here's our switch pin. It connects to this tilt switch. Excuse me. Then create another integer. Oops, I skipped one. Create an integer called switch state. And right now we're going to say 0, meaning the switch is off. So it's going to start by thinking that switch is off. And then we're making another variable called previous switch state, and we're going to make it equal to 0. So it just believes it's always been off. Okay. Then it says a variable to choose which reply from the crystal ball. We'll get to that in a little bit. This looks a little strange on my screen. I'm not sure if this looks darker to you. I think that's just a mistake. I don't know. That doesn't mean anything. We're just creating an integer, and right now it has no value. Okay. You could probably give it a value, but I think we don't want a value, and we'll see why later. Then void setup. This is something that runs right away when we turn the Arduino on, and it would run this entire section. You'll see it's in between the brackets. if you're ever programming and something's not working, normally it's because you didn't close your brackets. So I like to highlight one side to the other to make sure I have it. This is going to run and then once, and then the loop will continue to run. So it says set up the number of columns and rows on the LCD. So this would be something as defined in the liquid crystal library. You would have to say LCD begins 16 to 2. So it says number of columns, 16 columns, 2 rows. That would probably just be the LCD that you're using. This one is a 16 column, 2 row one. Okay, if you have a different LCD, you might have to say 14 characters and 3 rows. I'm not sure how your LCD will be set up. If you bought the starter kit, I'd imagine it's going to be the same. Then set up the switch pin as an input. So they're saying switch pin, and if we look up here, that's number 6. So they're saying this is an input. So please take electricity in and read some sort of value from it later. Then print a message to the LCD. So it's going to say, it says LCD print, ask the, and it's in parentheses, in quotations, that's the word. And it will say ask the, okay. And then it says set the cursor to column 0, line 1. Line 1 is the second row since counting begins with 0. Remember that's something I've talked about a lot before. 0 is the 1, pretty much 1 in programming. So 0 is always the first value. So cursor to column 0, so the first column on the line 1. Line 1 is the second row. Okay, so I believe it's going to say ask the, and then crystal ball. If you wanted to change that, you could totally change it, right? You could change it to whatever you want. You could say, you know, ask Mr. Duda. And you could say a question. Okay? You're a hacker now. You just hacked someone's code. Good job. And then it's going to run this void loop. This is what keeps running forever. So check the status of the switch. So they're saying, hey, the switch state is the digital read of the switch pin. So what they're saying is we started with switch state being 0, so it was off. But now what we're going to do is we're going to read the switch pin, which is number 6. And it's going to read whether this switch is on or off, and then store that value as switch state variable. If that variable has changed, is not equal to the previous switch state, okay? And if the switch state is low, then reply one of the random choices written below. And these are all the cases, all the things that it could choose from, okay? So if the switch state basically is changed, if the switch state is low, reply a random one, 0 through 8. So there are 0 through, right? Well, I guess, hold on. Yes, there are not 0 through 7 because there are 8 total choices here, okay? So randomly choose one of these replies down here. Clean up the screen before printing a new reply. So it's going to get rid of ask Mr. Duda a question, okay? It's going to get rid of that. And set the cursor to the first line. First column, first line, because that's 0, 0. And then print the ball says, I want to change that. Mr. Duda says, right? And then it's going to say the reply, okay? Mr. Duda says, awesome. And then it's going to save the current switch state and then keep going. Now you can change these all you want. Let's do this really quickly. Let's start our simulation. I'm going to start it. I'm not sure why it didn't say the Mr. Duda thing. Interesting. What did I do? Now, just because of being a video, I'm just going to copy and paste that code again and make sure that I didn't make a mistake. I did click one time and I didn't mean to while I was talking, so maybe that's why. It should be displaying things, and for some reason it's not. Now, what I'm going to do to solve that is maybe they have a different wiring. If you're doing this in person, with your Arduino, it should work. It should work, okay? The big thing I'm going to look at here is this 12.11.5.4.3.2, and I'm going to look at the code that they wanted us to have, okay? And actually, I'm going to go to the last page. Maybe it's working for you guys. Maybe I need to change my potentiometer, make that screen brighter. Maybe I don't. There we go. I solved it. Now, I wanted Mr. Duda there. So, so that was not my mistake at all. I mean, it was. I should have changed the potentiometer. So let's change that again. Ask Mr. Duda. Now it is upside down. I recognize that, and we could have flipped that around and wired it differently and all that stuff. I'm not going to do that while you're watching. Ask Mr. Duda a question. Awesome. Now let's start it. Change that potentiometer, okay? It says ask Mr. Duda a question. Then we shake it in real life. We change that switch. The ball says no. And then I could ask it another question. Now you could put a delay on it. You could say delay 1,000, which would be milliseconds, and then display, ask Mr. Duda a question again. They don't have that in here. You can definitely mess around with the code. But I could ask another question. Did Mr. Duda get 300 subscribers today? Then we switch that state. Most likely. And yes, I did get 300 subscribers today. Thank you, Magic 8 Ball. So feel free to read through it. Hopefully that made sense to you. If you have questions, ask in the comments. This is one of my favorite ones to share with my students because they love it and they think it's hilarious when you can change the replies. Sometimes when I give it to them, they choose inappropriate replies. I'm not going to comment on that, but you can have some funny replies. So I hope you have fun with this. If you have this in person, it's so much more fun because you can like bang the table or shake it a little bit, and it works really well. So thank you so much. Once again, I'm Mr. Duda with STEM with Mr. Duda. Please like and subscribe, and if you know anyone that would benefit from this or that would like this, please share with everybody and everybody. I'd love to eventually get more people watching these so they can benefit from it. So have a great day. I'll see you later.